is Irsyad, and in this video, I'm going to discuss a past year question from KMK Set 3. So let's move on to the first question. The question states that the ratio of relative abundance 35 Cl and 37 Cl are equals to 3.13. So the question also provides us with the relative mass of two isotopes, which is this right here. So what I like to do when solving an chemistry equation is to extract out the information given and write it back. So this here. So the tricky part about this question is when they give the relative abundance and the ratio from. So but don't worry about it, bentuk yang sebenar ratio ini adalah 3.13 over 1. So the question asks for the relative atomic mass of the chlorine. So the first step is to find the average atomic mass of the chlorine. So the formula for average atomic mass is KMPK. Means K for overall abundance and me for overall mass. So this right here are our abundance of Cl and this right here are our mass of Cl. So just put the value in and in the formula and we will get 35.45 AMU. So remember, for average atomic mass of the unit of average atomic mass are AMU. So now we can go to the next step, which is find the relative atomic mass of Cl. So the formula to find relative atomic mass of Cl is average atomic mass that we just got from the calculation previously over the mass of one atom of carbon-12. So just put the value in and the final answer we will get are 35.5. Now reminder to you guys, for relative atomic mass, it doesn't have any unit. You can see here. So the final answer is just the value that you got from your calculator. So remind that. So now let's move on to the question number 2. So hydrated potassium carbonate has the formula K2CO3H2O. Now the information given from the question are the initial mass of the hydrated salt, which is 10 gram, and the mass of hydrated anhydrous salt after heating, which is 7.95 gram. So the question asks us to determine the value of S in the formula. So as you can see, the value of S right here are the value of the mole number for H2O. So the first step is to find the mass of water loss. To find the mass of water loss, we need to take the mass of hydrated salt minus the mass of anhydrous salt, which means 10 gram minus 7.95 gram. So we end up with the answer of mass of water loss is 2.05 gram. So the second step is to find the mole of anhydrous salt of potassium carbonate. So the formula for mole are the mass over molar mass. So the mole for potassium carbonate are 7.95 gram over the molar mass of potassium carbonate. So the mole for potassium carbonate are 0.0575 mole. So next, let's find the moles of water loss. So same like with the previous calculation, we just need to put the mass of water over the molar mass of water. So we end up with the mole of water is 0.1139 mole. Now to find the value of X, we need to find the ratio of moles of water to moles of potassium carbonate. So X equals to moles of water over moles of potassium carbonate. So let's put the value that we got from the previous calculation and put it into formula. So this right here, and we end up with answer of 1.98. So bundlekan and we're gonna get 2. So then we're gonna make a conclusion. Thus X equals to 2, meaning the formula of the hydrated potassium carbonate is K2CO3 2H2O. So now let's solve for the question number 3. So let's out the question first. A 50 ml of H2SO4 solution containing 52% H2SO4 by mass with a density of 1.48 is used to prepare a 0.2 molar H2SO4 solution. So the information given are the initial volume of solution, which is 50 ml, and then the percentage by mass of H2SO4 52%, and the density of H2SO4 1.48 gram milliliter, and the molarity of H2SO4, which is 0.2 molar. So the question asks us to determine the initial molarity of the H2SO4 solution and the final volume of H2SO4 solution after the preparation. So let's find the initial molarity first. So to find the initial molarity first, we need to find the mass of the solution. But how? So what are we given are the density and the volume of the H2O4 solution. So we can use the formula of the density, which is density equals to mass over volume. So just put the value that we are given inside the formula and we're gonna get the mass of the H2O4 solution is 74 gram. Now, the next step is we're going to use the percentage by mass formula here to find the mass for the solute. Percentage by mass formula are mass of solute over mass of solution times 100. So we are given that 50% are the percentage by mass and the mass of solution are 74 gram. So put the value in the formula and we're gonna get the mass of solute are 38.48 gram. So the next step is to find the mole of H2SO4. So the formula for mole are mass over molar mass. So we already have the mass of the H2SO4 that we got from the previous calculation, which is 38.48, and the molar mass is 2 plus 32.1 plus 60 times 4. So we're gonna get the mole for the H2O4 solute are 0.3923 mole. So now since we have the value for mass of solute and the volume of the solution, we can find the initial molarity. So the formula for molarity are the moles of solute over volume of solution in liter. So means the previous answer that we got are 0.3923. We're gonna divide it by 0.05 liter. So the final answer for the initial molarity is 7.85 molar. So that's our initial molarity. So the final step is to find the volume of the solution. Volume of the solution. Since we already have the initial molarity here, we have our initial volume here, and we have our final molarity here. So here, we can see that we can use the formula M1V1 equals to M2V2. So our M1 are 7.85 molar here. Our V1, initial volume are here, 50 ml. Our M2 are here, 0.2 molar. So substitute the value into the formula here, and we're gonna get the final volume are 1.96 liter. So remember, when we calculate using anything that are linked with molarity, we need to convert our volume that are given for the question to liter here. So let's say the volume are given are 50 ml, then I convert it to 0.05 liter. So and the unit for the molarity are the M, capital M. So that's all from the question number 3. For the final question, the first question asks us to write a balanced equation for the chemical reaction. So let's see out the question first. The reaction of calcium carbonate CaSO3 with hydrochloric acid Hi produce calcium iodide CaI2 and H2O and carbon dioxide CO2. So to write the balanced question, just write it back. So calcium carbonate react with Hi produces CaI2 and H2O. So now we need to balance it. As we can see, everything here are balanced. Ca are balanced, C are balanced, and O are balanced. Except there's two things that are unbalanced yet, which is H and I. As we can see right here, on the right side, I and H have 2 mole. But on the left side, it only have 1 mole. So what we need to do is to put 2 in front of the Hi to balance the equation. So that's the answer. Now for the question 2, they asking us to determine the limiting reactant of the reaction. So the info given are the mass of the CaSO3 30 gram, the volume of the Hi 50 ml, and the molar of Hl 2.0 molar. So to find the limiting reactant first, the first step is to find the mole of the reactant, which is CaCO3 and the Hi. So to find the mole of CaSO3, we can use the mole formula, which is mole mass over molar mass. So mass of the calcium carbonate are 30 gram over the molar mass. So the mole for the calcium carbonate are 0.2997 mole. Now to find the mole for Hi, for this one, we can use the molarity formula because we are already given the molarity 2.0 ml and the volume of Hi 50 ml. So mole of Hi are equals to molarity of Hi times volume of Hi. So mole of Hi equals to 2.0 molar times 0.05 liter. So now the final answer for the mole of the Hi are 0.00 mole. So now what I suggest is to label the mole that we calculate, this 0.297 and 0.1 mole, to label with available, so we're not going to confuse for the further step. So after we found the mole for each reactant, now we can do stoichiometry. To find the limiting reactant, we need to compare both of our reactant, which is CaSO3 and Hi. So we can find the value for one of the reactant needed for the reaction. So from the equation, 1 mole of calcium carbonate equivalent to 2 mole of Hi. equal to 2 mole of HI. So where do I get 1 mole and the 2 mole? Yes, I get it from the equation right here. So 1 mole of calcium carbonate and 2 mole of HI. Since I want to find the value of HI, I need to write the mole of calcium carbonate available down here. So 0.297 mole calcium carbonate equivalent to X mole of HI, since that's what I want to find. So the concept of stoichiometry are this: naik atas bahagi darat, pergi kanan kita kiri darat. So value of mole of HI needed are 0.297 mole times 2 over 1 mole. So mole of HI needed are 0.994 mole need. So that's the mole needed for the reaction. So as we can see right here, since we have the mole available and the mole of needed for HI, we can compare them. There for mole available and mole of needed. So since mole of HI needed 0.5994 are more than mole of HI available 0.1, we can conclude that HI is the limiting reactant. So the concept of determining the limiting reactant are like this: if the mole needed are bigger than the mole available, that is the limiting reactant. But if it was the otherwise, mean the mole of available are bigger than the mole of needed, that is the associatant. Now, there is a shortcut. So for a shortcut to determine the limiting reactant, so first we need to find the mole for each reactant. So like this we have the mole available for each reactant. Now, we can divide the mole of the available with the number of mole right on the front from the equation. So then when we calculate it, the one with the smallest value, we can conclude that that is the limiting reactant. So here are the cheat code right here. For the last question, ask us to calculate the mass of CaI2 produced. First step is to compare and find the mole of CaI2 using stoichiometry. To do so, we need to compare CaI2 with the limiting reactant HI. So why we are comparing with HI? Because CaI2 are the products, and products always depends on the limiting reactant. And one more thing, when we are comparing, we need to take the mole available and not the mole needed. So 2 mole of HI equivalent to 1 mole of CaI2. So mole of available of HI is 0.1 mole, equivalent to X mole of CaI2, since that's what we're going to find. So mole of CaI2 equals to 0.1 mole times 1 mole over 2 mole. So the mole for CaI2 produced as 0.05 mole. So the second step is to find the mass of the product of the CaI2 produced. So to find the mass of CaI2, we can use the formula mass equals to mole times molar mass. So mass of CaI2 produced is 0.05 mole that we got from the previous calculation, and the molar mass of CaI2. So the final answer is 14.69 gram. So that's the mass of the CaI2 produced. So that's all from me. Thank you very much.